Swayam Prabha. Digital India. Educated India.
Hello students. So last time, the last couple of classes, we saw some strategies for low embodied carbon, for achieving low embodied carbon buildings. We saw some of the basics. We will go a little intense into the further on the strategies for low embodied carbon. So, the sequence of what we would study would be probably we will look at material selection strategies for low embodied carbon, the hierarchy of the strategies, then example of material considerations for specific elements, low embodied carbon solutions for building. We would look more into whole building design and one for one material substitution, specifications, reduction of amount of needed materials throughout entire life cycle. Probably we would just mention some of the tools for implementation but not get into too much detail because it becomes a little advanced. But I wanted you all to at least know these terms and therefore I have included this in the contents. And those are the current tools for implementing. How do you assess? How do you kind of measure it? So the tools for implementation, there are some of these. They are called as Athena Impact Estimator for buildings, the Carbon Smart Materials Palette, Embodied Carbon in Construction Calculator, that is EC3, ECCC and therefore EC3, and one click LCA. But we will not go into too much depth or even any depth of these tools, but I want you all to know that some of these tools are available, so that if you are interested, you can go ahead in trying to explore and use these tools. Now, we had already seen how material selection strategies for low embodied carbon, how that can have an impact. Now, we already know that the construction sector has been proven to be one of the contributors to the increase in carbon dioxide and other greenhouse gas emissions also. Now, carbon emissions accordingly need to be managed by enhancing the use of low carbon building materials in as many construction projects as possible. To enhance the use of low carbon building materials in construction projects, every construction professional plays an important role in monitoring and selecting the best materials for the project. All this, remember, happens at an early design stage and therefore you have the power to intervene at that stage. Embodied energy has been emphasized as the energy that occurs based on the building materials and the techniques used in the construction. Now, minimizing the embodied carbon footprint of buildings is crucial for achieving true sustainability in the construction industry. Now, this involves careful selection of building materials, prioritizing those with inherently lower carbon content. How does that happen? This is a recall class and recall of last couple of classes. How does that happen? One of the thumb rule is that you need to use natural products, and that will lead you to have components which have low embodied energy, low embodied carbon, and sequestered carbon will be high in those products. You should employ best practices throughout the material life cycle. Now, let us look at a small breakdown of key strategies in the forthcoming slides. We have already seen that reinforced concrete frame structures, they are used in constructing a building. While for claddings and openings, we use glass and aluminum. These are our conventional material choices. Materials such as aluminum, steel, concrete and bricks, they have high embodied energy. What role do you have in lowering the embodied energy of that building by using alternate materials? That is something you have to think. But let us look at the other strategies to come. Now, let us look at the hierarchy of strategies. Now, reduced material use is a very important strategy. We have already seen this, that if we need to reduce our building material usage, we will have to go for very impactful strategies and optimize the design to minimize the total materials required. That has a direct implication on build less, build smarter. This ranges from questioning the necessity of building something new to optimizing the setup and location. You need to renovate existing assets rather than construct new ones, or mix and optimize uses rather than plan for single use. And there are three strategies to do this. One is modular construction. Off-site production of parts results in reduced emissions and work disruptions, which help even in the efficiency. So, what you do is you need to pre-cast or pre-construct components in a particular place, and if you do it en masse, then the savings due to multiple transportation of materials and even construction processes gets reduced, and therefore off-site production of parts and bringing it on site for its erection is an important strategy. Controlled dry environment of modular construction can save water consumption. Now, the way curing is done on a particular building which is cast in situ is very different from curing that is done en masse or in a factory. You can save a lot of water. It allows scrap and other materials to be recycled, which reduces waste and which results in less embodied carbon consumption. So, with modular construction and prefabrication, a lot of energy can be saved. Next is structural optimization. Do not use more than it is needed. The spacing of columns, the size of columns, all these need to be optimized. Optimized not only for its structural strength but also for its functionality. And you can use softwares to optimize their sizes and their location. What I mean is, suppose columns are needed at a particular place. Suppose you need columns at a particular place. Do not double guess and have columns at A meters or X meters. You need to use appropriate tools to understand whether whether it is sufficient to have columns at X plus X dash meters distance, and that will save a lot of energy. Also, what is the functional grid size, whether it is x or x plus x dash. So, you need to optimize on both of this. For that, softwares along with your understanding of the functions to take place, both of it can be combined and we can arrive at a optimized dimension of the structural element as well as the placement of the structural element. Then let us look at multifunctionality. So, these are design elements to serve multiple purposes. So, when you have a window, when you have a window sill, you can consider the purpose of the window. For example, if you have a window which is placed, glazing which is placed towards the inside, the inside will be flush, but at the same time, suppose you have a window which is placed like this, you can use this space. This can act as a multifunctional space too. So, you need to look at design elements to serve multiple purposes. So, this window will give you some kind of it will give you serve its purpose of lighting, ventilation, and also some kind of personalization of spaces which is needed. Whereas this option A will not have personalization of spaces as against option B. Then let us look at how using low carbon materials, how do you select materials with inherently low embodied carbon? So, building with lower carbon materials has the potential to significantly reduce a building's embodied carbon. These options include using low carbon concrete or even alternate structural systems, like using mass timber or hollow core blocks. Now, using low carbon materials, it kind of includes that you select materials which inherently have low embodied carbon in it by virtue of its source from where you extract or manufacture. What are the thumb rules of key of doing this? First is you use renewable materials. If you want to have low embodied carbon, use renewable materials such as timber or straw, bamboo, cork, wool, etc. Now, these have lower embodied carbon compared to non-renewable materials. What are renewable materials and non-renewable materials? We will see later during the later courses, later classes. Next is considered recycled content. Now, this reduces carbon footprint compared to virgin materials. Now, you see slowly I have introduced another terminology, carbon footprint, and that is my job, to instigate you to learn more and more about low energy, low embodied energy, low embodied carbon emission, low carbon footprint,